Alright, solving any quadratic equation. It says solve each quadratic equation using a calculator if possible. Round answers obtained from your calculator to the nearest thousandth. Remember, the thousandth position is 1/10ths, hundredths, thousandths. So 3 decimal places. If the roots are imaginary, leave answers in simplest radical form. So what I suggest is, when you work on this claw, okay, that you plug in the function into your calculator, you graph it. You can do the zoom 6 if you like. And notice that the solutions are real. They touch the x-axis. So you're going to use your second trace, okay, and you're going to find your solutions. So remember the word solutions. Remember that when it says to solve, you're looking for the roots. Okay? Here's the word right here, roots, also known as zeros, also known as x-intercepts. So since they're real, we can find the 0. We go left of it, enter, right of it, enter, and enter one more time, and there it is. There is your solution. X equals -2.5. Okay, and we were going to sketch that graph, so right here is one solution. Okay, we can eyeball the second one. Here is at 1. If we want to verify that to make sure it is at 1, 0, go second graph, and right there, 1, 0. So we have a solution at 1. Now remember, when you're doing a sketch, you need to have at least 3 points. So I'm going to go ahead and look at my calculator, at my table, see if I can identify. No, the vertex isn't going to be really easy to identify. So let's go ahead and get it. Second calc, and it's a minimum. No, the A value, yeah, it's a minimum. The A value is positive, so it's a parabola opening up. So it's going to be a minimum. Left, enter, right, enter, enter. So it looks like our vertex is at -3/4, -6.1. So, you know, approximating it. So about right here. And then we'll just go ahead and sketch it. Okay, and we said the other solution was at 1. Okay, number 2. Let's see if these solutions are real. So I know you don't have a graphing calculator at home. Some of you do, but most of you don't. But don't forget about Desmos. That's your online graphing calculator. Now, it doesn't have a table function, but you can graph with it. Don't forget, we have to move everything over. We have to set the equation equal to 0. So I'm going to cancel those out, move them over here. Okay, so 3x squared Okay, let's graph it. Okay, notice it doesn't cross the x-axis, so we do not have real solutions. We have imaginary roots. Okay, so when we have imaginary roots, I'm just going to go ahead and sketch this one. Not even going to get the 3 points here. We're going to use the quadratic formula. So we're going to identify A, B, and C. We're going to plug them into the quadratic formula and then find our solutions that way. So x equals negative b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. So we end up with 3. Now our discriminant under here should turn out to be negative because we have imaginary roots. So we got 9, and then 4 times 3 is 12, and then 12 times 7 is 84. So we're going to have 9 minus 84. Okay, over 6. Okay, so some of us need some more help simplifying radicals, so watch closely. So first of all, the negative 1, this is negative 1, makes an I. And then the square root of 75. Well, I'm not sure if there are any factors of 75 that are perfect squares. So let's go to y equals 75 divided by x. Okay, and then you go to your table, and let's look. 1 and 75, let's see, first perfect square is 4. No. Then 9. No. Then 16. No. Does not look good. 25, ooh, check it out. 25 is, and 3, so yes. So the square root of 75 is going to break down to the square root of 25 times 3. And the square root of 25 is 5. So we're going to have, put the number first, so 5i radical 3 over 6. Now, we want to check this number, this number, this number. Is there any number that goes into all 3 evenly? No. So, can't simplify it any farther. So that is your complex solutions. All right, let's look on the back. I think you kind of got the idea. So let's skip number 3. What is the maximum point? Notice the a value is negative, so that means it's going to be opening down. Okay? We're looking for the maximum point. So that would be your vertex. So let's plug it in and find it. Okay, I'm going to go ahead and do the zoom 6. I like that. Zoom 6. There it is. There's our maximum point right there. So we're going to do second trace, maximum. Okay, left, I'm to the left right now, so I'm going to go to the right. Enter 3 times there. So 0.75, negative 2.875. There's your maximum point. Okay, x-intercepts. So again, what are we looking for? We're looking for the points where it crosses the x-axis. Hoping to keep this under 10 minutes, so let's see if I can do that. Okay, let's graph it. All right, there they are. So we need to get these 2 x-intercepts using second calc and do the zeros. So when they do ask you for x-intercepts, your answers need to be in the form of the root 0. There's 2 of them. So you got to calculate these 2 numbers. And we're at 10 minutes. So I'm pretty sure you know how to do that. We'll see you tomorrow.